Today we're tackling one of the most powerful creational patterns in software design, the abstract factory method. So what exactly is the abstract factory pattern? In simple terms, it provides an interface to create families of related objects, without specifying their concrete classes. Think of it as a blueprint for a factory that produces a whole group of compatible products together. The key ideas here are, it creates related object groups, it ensures consistency between those objects, and it promotes loose coupling in your system. That quote at the bottom says it perfectly. Abstract factory creates families of related objects together. Now you might be wondering, why can't I just create objects independently? Great question. In complex systems, we often deal with multiple related objects that must work together. If you create them independently, you risk mixing incompatible objects, and it becomes really hard to maintain consistency across your codebase. Related objects must always be used together. Mixing incompatible ones causes bugs. And maintaining consistency manually is painful. We need a better way, and that's where Abstract Factory shines. Here's the core idea. Abstract Factory defines an interface for creating multiple related objects, while the concrete factories ensure that all created objects belong to the same family. Now here's a comparison I want you to burn into your memory. Factory method creates one object. Abstract factory creates a family of objects. That single distinction is what makes this pattern so powerful and so frequently misunderstood in interviews. Let's make this real. Imagine a UI system that supports both a light theme and a dark theme. Each theme needs matching components, a button and a text box. The rule is simple. Light button must always pair with light text box, and dark button must always pair with dark text box. You cannot mix them. The abstract factory pattern is exactly what enforces this rule. As the slide says, let's build this step by step. Step 1. Define your product interfaces. We start by creating iButton and iTextBox, each with a render method. These interfaces act as a contract for all implementations. Notice we're not saying how to render, just what should be done. This is the foundation of the open/closed principle at work. Define what products should do, not how. Step 2. Implement those interfaces for each variant. We create light button, dark button, light text box, and dark text box. Each one implements the render method for its theme. Notice how light and dark products are separate, but each forms its own consistent family. Each family provides its own implementations, clean and isolated. Step 3. Define the abstract factory interface. We create IUI factory with two methods, create button and create text box. This interface declares what the factory can create, but not how. It returns abstract types, iButton and iTextBox, so the client never needs to know about concrete classes. The factory defines what to create, not the actual objects. And step 4. Implement the concrete factories. Light theme factory returns a light button and a light toolbar. Dark theme factory returns a dark button and a dark text box. The client code simply works with IUI factory and never has to worry about which theme it's using under the hood. Consistent families, zero mixing of incompatible components. Beautiful. Now let's talk interview prep, because these questions come up a lot. 1. What's the difference between abstract factory and factory method? 2. When would you use abstract factory over simple dependency injection? 3. How do you add a new product to an existing abstract factory? 4. Can you combine abstract factory with DI? And 5. How does it relate to the open/closed principle? Pause here, think through each one, and drop your answers in the comments below. So what should you take away from today? Abstract factory ensures related objects are created together and remain consistent, without exposing their concrete implementations. You'll find this pattern everywhere in the real world. In EF Core's database provider factory, in cross-platform UI frameworks like MAUI and Avalonia, and in cloud SDKs like AWS and Azure, where each cloud has its own service family. Remember, use abstract factory when your system needs multiple related objects that must always work together. And that's a wrap on day 3. If this helped you, please like, share, and follow us at Fundamentally Clean on Instagram. Coming up next on day 4, we're diving into the builder design pattern. Don't miss it. Follow the series to master all 23 design patterns with practical C# examples.